vector.create.
Yes.
Yeah, that's what we had said last week.
Yeah. So there's quite a few in that file. Yeah. Okay.
You have so for gather prefetch int32, for example, there's the overload here that takes the T and the T2, where T2 is where T is the mask. So uint always, it looks like. And then T2 is the indices, which you've got is int long and u long. Is that meant to be u long as an option? Is there a variant of the indices that treats the index as unsigned, or is that just convenient supporting u long? Since 2's complement arithmetic will compute the same regardless.
Not sure which instruction you were referring to because the page scrolled.
Oh, it's a PRFW, for example.
PRFW, yes. You're saying we have a variant
that takes an unsigned index.
I figured that was just convenience. Because I was wondering about this before as well. But Alan, do you?
I'm trying to remember. Yeah. It would have come from the ACLE, so it would have been available there.
Because for the normal instructions, in this case, it has no difference.
Right. This sounds like it's a convenience in the ACLE. And that's transferred over here.
Oh, no, sorry. There is a difference, but the instruction takes a modifier, so a sign or zero extent, which I'm guessing is why the overload is there.
So should that have been uint as the second instead of ulong, since the addressing will be 64 bits?
Correct. So the base address would be 64-bit and the offsets would be 32.
Okay.
So what are we changing?
Yeah.
It's in a couple of the parameters. So we're removing the overloads that take index as a long.
Yeah,
we don't need those. And then there's a couple overloads that are taking where the comment for the generic types, where it says, for example, on gather prefetch int 32, you've got uint int, uint long, and uint ulong, where it should have been uint uint, because the 32-bit index can be 0 or sign extended.
So there's actually an overload as well that takes a long and the modifier, but it does pretty much nothing.
Okay, and I don't think we need to expose that unless people go and ask for it, since it's not behaviorally different.
Yeah, the only reason you would have that particular case is because the address is also multiplied by 2.
Okay.
But I think that's just addressing mode, so you can deal with it in the.
Yeah. .
So all I heard was some of the type annotations are wrong, and Tanner knows which ones. So that's basically my takeaway. Go back to the comments because I don't know which ones you're referring to, but it's fine. It's like I don't think that it will change our API opinions here. All right, so then can we talk about gather vector, or should we scroll further?
Yeah, I think we can move to gather vector. Gather vector is basically exactly what it says. It is doing a gather operation for vector count elements using the addresses. So it's essentially the same thing as prefetch, but instead of prefetching into cache, it actually loads and produces a vector in a register that you can then consume. And so it's got two variants here, one of which directly takes an address, and the other of which takes a series of bases. In this particular case, because it is a pointer overload and you don't have pointers in generics, I do think we want to have both overloads explicitly rather than relying on vector create with a cast operation and pattern recognizing on that one. And then we had named base address in the load API.
Yeah, I was about to ask that. So the gather vector with T star base. I think we called that one address in single load.
Yeah, and then we kept bases when it was multiple. It looks like.
We at least did for compute 32-bit addresses and friends.
Yeah, we did compute 8-bit addresses taking in vector of T bases. Which is maybe inconsistent, but I think we discussed that and had a reasoning. I just don't remember what that reasoning was.
Yeah, I'm sort of looking at that and wondering why we didn't name it base addresses or addresses. All right, did you catch those notes, Emo?
What was the question?
So anywhere that it says T star base,
Yeah,
becomes T star address, but the vector of T bases stay vector of T bases.
So I'm confused. You basically want to change the name of the parameter to add to a base, to address, or
the ones that are singular base should be renamed address because that's what we did with the other load.
But then the vector ones you leave as bases.
Unless people want to reopen that discussion and say we should name it addresses or base addresses or Tuesday or whatever we want to call it.
Tuesday.
I like addresses for consistency, but I also remember we discussed this last week, and for some reason we opted for bases last week, and I don't remember why.
I'm wondering if it was just first, because looking at it in the proposal, those are the top because it was alphabetical.
If there wasn't any actual reasoning given last week, then I prefer addresses.
I think
personally,
I do
for consistency.
Okay, I'll just drop a note in that other issue that says we retroactively renamed those parameters.
One quick question, Tanner, and this is maybe something for later, but some of these instructions, for instance, aren't available when in streaming mode, unless a particular SME extension is enabled. And I'm not sure how you'll test that later, but just thought I'd mention it.
Streaming mode is interesting because it's a it's a net new ISA that can be toggled on and off and impacts existing instructions in SVE. And we've not really gone through to the design point on the JIT side, even on how that would need to work and how it would function in the face of already compiled methods and things like that. So I think we still need to have a little bit of a discussion point on that between ARM and the runtime team to determine if anything needs to be done there, and if so, the solution is likely to move those special cases into a nested class, potentially named sve.non-streaming or something.
Right. Thank you.
So I think we can just continue with the approval here and then have the note of we need to, which we already have one, kind of tracking that on the streaming related issue. So we can follow up and make sure that that's finalized in the next month or so to ensure the correct API surface there.
Tanner, can you explain why on the highlighted line we have vector of T2 bases and then a parameter called offset, and the one above it we have T star and a vector of T called indices instead of offsets, and then somewhere above it we have one that calls offsets?
I believe indices. So indices are actual indices. So it's value times size of T plus base, whereas offset is byte offset. And so it is not being scaled like an index would be. It is just base plus number of bytes. That's correct, right, Tamar and Alan?
Yeah, so
Yes.
the first,
yeah,
the second one, the bases themselves are the base of the address, and the first ones are offset. Yeah.
Okay, so it is correct that the highlighted is vector of T2 and not vector of T2 star. Because I was having the same thing on.
Yeah, it wouldn't be vector of T2 star because it's specifying multiple base addresses. I think we have to differentiate the indices versus the offsets overload by name. Because you can't have, because they'd conflict otherwise.
Yeah, I was trying to figure out how the signatures make sense. Is a gather.
Do they actually conflict? Because it looks like those two sets are different, right? You never have int on the first one, for instance.
3 lines above the highlight could be int, I guess, and then the two lines above the highlight would be int uint.
I think even if they don't conflict because they're functionally different in what they do here between byte offset versus indexing, I think we need to differentiate by name to avoid confusing users.
Right, because the 3 above is called offsets. And so it's if T1 and T2 are both int, then it's offsets. And if T1 and T2 are differ by sign, then now it's indexing instead of byte offsetting, which, yeah, I think those need different names.
Yeah, so with system runtime compiler services unsafe, we have add, and then we've got add byte offset. So maybe we just want gather vector and gather vector from byte offset.
So the ones that take a parameter
Offsets
called
would be
offset,
yeah.
scan a suffix from byte offset.
I think so.
Did you get that email?
Or with byte offset, or maybe with offset.
All of those?
The ones I mean, you could just take it as a meta note. Gather vector with where the last parameter is offsets becomes gather vector with byte offset from byte offset. Mit dem Offsetten.
Alan, Tamar, do you have a preference on the suffix there?
No, not particularly.
No.
With offsets feels good enough to me, maybe. Like, I don't know that byte needs to be in the, it doesn't hurt.
Yeah, the only reason I
one?
suggested byte offset is because that's what we did with the unsafe APIs.
Okay, if we have prior art, that's good.
What are we doing with the
Yeah.
singular one? Are we removing that as well in favor of vector.create, or?
Yeah, the singular one where we opted to say we don't need them because vector create is trivially pattern matched there, and if for some reason in the future we decide that they are needed, we can come back and add them.
Yeah, and the highlighted line, so both the vector of t offsets and the individual long offset, those should, like the ones where you've named the last parameter offset or offsets should go, or should gain the suffix.
I'll be back in a few minutes. I'm double booked.
Yeah. I would have taken over if I had your notes. Ooh, now I get 2 computers. I can screw up twice as much. Okay. Take. Oh, so like the highlighted line that just has a singular long offset, we're actually deleting those.
Yeah.
Okay.
So we should only have looks like 2. We should basically only have the first 4 entries or so. 6 entries, something like that.
Okay, doesn't look like he's been making all these changes in line. Okay, so like these are deleted.
Yeah.
But these stay.
No, those are deleted too because they can be trivially patterned over vector create and then index.
Okay.
And that way we avoid the additional API bloat to corelib, and if we determine that it is beneficial to expose those in the future, we can revisit that and do it at that time. That way we don't end up adding 10,000 APIs to corelib. We only add like 4,000.
Okay, so now I think we're at just the 0 extend, which will be pattern match off the previous comment.
Yep. I did have a question for Tamar or Alan here. So this is gather vector byte 0 extend. The mask, however, is taking an int or a long. So is what this is this functionally going to only read, since this can only read vector of int dot count elements from the gather, that's why we're not using the byte mask, correct? That's why it's int instead of byte, because we're only reading vector of int dot count.
Or we'll talk about the currently highlighted instruction.
Yeah, for gather vector byte 0 extend.
Sorry, you lost me a bit there. So the mask, I had to look at this API a couple of times myself, because the mask is supposed to apply to the basis
Oh, the mask is for the bases.
Yeah, because it basically it reads the active element in the base address, and those gets loaded in. Now,
Okay.
my assumption for the reason for the T and T2 here is that because the types are the same size, and so we chose to model the mask after the elements that are being produced instead.
Okay. Because that avoids the need to disambiguate by overload resolution. And it functionally ends up
Being the same.
it ends up working because you can also, even if it actually works on bases, you can consider it as if it's applied to the result. So yeah, that makes sense to me.
Because in the result, those elements would be empty as well, yeah.
Yeah.
But I will admit it was a bit confusing to read.
Okay, so they make sense, and the only change here is we're modifying the ones that say offsets to be gather vector byte 0 extend with byte off or with offsets or with byte offsets, whatever we decided, and then we're dropping the ones that take the scalar offset.
Okay, and then I moved down to highlighting that one to ask, where did you want the offset marker to go as a suffix or before 0 extend? Suffix sounded fine when you said it.
Yeah, on one hand, they group better if you do gather vector with offset, or gather vector byte with offset. I think that also fit. I think the best fit here is gather vector size, so byte, with offset 0 extend, because that describes the order of the operations happening. We're gathering a vector. We're gathering a vector of a particular size with or from the offsets given, and then we are 0 extending that up to the target size. Rather than if you put it as an actual suffix, then you might misinterpret it as we're 0 extending and then adding the offsets onto that or something.
All right, so gather vector byte with byte offsets 0 extend.
Yeah, I think that follows the actual flow of operations.
Okay. Yep. Looks slightly weird, but
yeah, it doesn't flow as smoothly, but it follows the order of operations, which is what we've done elsewhere.
okay. Given your type pairings on the first gather vector int 16 sign extend, I'm confused. How is long U-long fit in with an int 16?
So int 16 is the input type. So the H at the end, it reads them from memory as 16-bit values and then extends them to whatever T values there.
Yeah, so we're reading a short and we're upcasting it to interlong. And the base address is always going to be unsigned, which is why T2 is uint and ulong.
But what's the short we're reading? We're reading it from where they live?
Yeah, from the actual memory. So the bases is effectively U short pointer.
Okay.
This is basically a read and upcast simultaneously operation.
So it reads from there as a signed 16-bit number and then upcasts it to the 32 or 64-bit number specified by mask.
Right.
Okay. I'm sure it makes sense to somebody. And so that int 16 really means int 16 because it's a signed 16-bit operation.
Right. And if we theoretically had pointers in generics, we would have specified it as vector short pointer bases.
I guess the question is though, since the sign extent already kind of implicitly says that it's signed, should it be the same as the other ones, so 16 bits? Or whatever the convention we chose before was?
I think the int 16 here is more explicit because so when you conceptually think about it, an unsigned type doesn't have a sign. And so a U short sign extended is always 0 extended. It's kind of like it's kind of like arithmetic versus logical shift, where they're the same operation for unsigned, but they're different operations for signed.
Yep, okay, makes sense.
Trying to see the. Yeah, like we have in the previous one, we have a load vector int 16 sign extend to uint 32, but that takes a short star. So the type was
right
actually embedded in it. And now I'm trying to find one of the ones that we renamed with size bit, which in the issue I opened is only in computing the address. So yeah, I mean it's a little confusing, but at least the previous ones we renamed because it was signed or unsigned was irrelevant, and this one is signed. It seems okay. Unless you want to change it, in case I'll write that down.
I think how it is makes sense here. I think what might be a simplification we could do is we're being overly verbose on some of the original load APIs technically, but then it's just a question of consistency versus not. So if we want the APIs that take a pointer directly versus the one that takes a bunch of pointers as a vector to be overloads of each other, then I think we want to keep both as is. And I think that's the better story. But it's really just confusing because we can't use pointers in generics. And so we have to use uint or ulong instead to represent the pointer.
And since you're mentioning that, should newint not be in the mix? Does that just complicate your universe?
We have reviewed. So we have previously reviewed and approved adding inint and inuint overloads to APIs. We've started that work, and the general statement we had given at that time was that for the intrinsics, if there's an API that takes int and long overloads where inuint makes sense, then we will review those as needed and get them approved and in.
Okay.
So I think for V1 here, we can start with just uint and ulong, and users aren't blocked. And then for convenience, if it's desired for the platform specific APIs, we can add inint and inuint.
Okay. Right. So 16-bit signed, saying int 16 makes sense. For 0 extend, are we keeping int 16? Are we renaming to 16-bit?
I think in our other APIs, we have, for simplicity, we have said that int 16 is always sign extend and uint 16 is always 0 extend, and that users can just swap the API they're using if they want one behavior versus the other. So I think we can drop gather vector int 16 0 extend in favor of it being gather vector uint 16 0 extend, which it looks like we don't have defined, so we would just rename it.
Okay, so that one just gains the U, or the 0 extend.
Yeah, 0 extend gains the U.
Okay, 0 extend should gain their use. And they'll gain infixes where necessary.
And that should be the full set.
And so everywhere here that says sbyte is
Sign.
doing 8-bit signed operations.
Yeah. And then we had the byte at the top.
Yep. Okay. Just looking at the way Emo didn't exactly upkeep the notes here. He just took the minutes and didn't take the changes. So that'll be what we get on this one.
That's fine. I will go in and clean up to match the notes after API review here.
Okay, so I have the notes on screen. We kept SVE prefetch type named as it is, but we renamed all of its members to things like load L1 temporal or load L1 non-temporal. The gather prefetches got renamed to bititude instead of typitude. And the gather vector X's, we renamed some bases to address. That we renamed bases to addresses. The with byte offsets suffix, and when it becomes an infix, things that get deleted. The gather vector int16 sign extend we left as is, but I wrote down and talked about it. And the 0 extend should insert the use. All right. Did the notes miss anything that anyone cares about?
I think that covers what we discussed.
Okay. Why are you doing things? Don't do things. That button? No. That button? That's good.
So this is the group of APIs that follows bit manipulation. The very first entry is one that I think we're probably going to spend a little bit of time discussing. The reason is we probably want to think about the name, and we want to decide if this is an API to expose on SVE or if it's an API to expose on vector of T directly as a cross-platform API, because it is a very important and highly requested API. The first API create series, the alternative names could be, for example, create sequence or create range. But the purpose of it is it effectively creates a vector starting from base in the first element and then incrementing by step for every element. So you can use it to trivially create a vector that is 0, 1, 2, 3, ... count, or 2, 4, 6, 8, etc. So it's very important for being able to write generic algorithms where you may not know the size of vector of T, because it can be any size. And so determining the right name here is fairly important. And I think the proposal for that one in particular should be that it should be on vector of T and not relegated to SVE in particular.
But you would also need it on the SVE because that's where it's coming from, right?
No. This gets into the realm of it's very similar to vector of T.count or vector.create APIs or create scalar, where they are so core as APIs that we didn't feel the need to expose them in the individual ISAs as well as via the cross-platform surface area, because there's only one that users should effectively ever use, and that's the general purpose version, because it will always do exactly what you want it to do.
Okay, and we just wire that up by magic without deferring it to somewhere else?
Yeah, internally it defers to the underlying instruction as intended. But the real question is do we want series, sequence, range, or another name?
So I don't like range, because range I think is way too easy to confuse with start and end. Like if you saw create range X, Y, you'd but create sequence or step sequence or whatever seems okay. Series, again, I feel like I don't think that's a name we use. I know in enumerable we call it enumerable.range, which is confusing.
Yeah, there's actually an API proposal open now for expanding enumerable.range to support a step amount as well. And one of the things that's being discussed there is it confusing that enumerable range is start length And the general agreement so far has been start length makes sense as sequence, and most people would equate range as being start end instead. And so in an ideal world, we'd have enumerable range, which is start end with an optional step amount. And we'd have enumerable sequence, or another name, which is effectively start count and then step amount. So just as kind of input on some of concurrent discussions for other areas.
Right. And then this is like sequence, except you don't get to pick the count. It gets picked for you by.
Yeah, that the count is implicit because it is it's fixed by the associated count of the type.
Yeah. I mean, I think sequence is a good name.
Yeah. So we'd have vector dot create sequence, and then correspondingly vector 64, 128, 256, and 512 create sequence for the parity that we want to maintain there.
All right, so that's vectors and system numerics.
Yeah, vectors, system numerics, and the rest of them is system runtime intrinsics.
Okay, so do we like base and step? Do we like start and step?
I like start and step because that's consistent with range and other places where we're using start effectively as the initial. And of course, start is inclusive.
Yep. And do we want step or step size? Does it matter? Do we care?
I don't have a particular preference. I like step just a little bit better. It's shorter, and I think it's understandable what it means in the context. It's what things like Rust and Python use for their APIs that do similar things.
Okay, so all right, so vector 64, vector 32.
Just 64, 128, 256, and 512. There's no vector 32.
It doesn't go there.
And then there's kind of a related question on if we want a well-defined property for the case of I want to create the indices of the vector. So it basically be 0, step 1, a property for that. But that's not necessarily important to review today or decide on unless we want to just go ahead and say, sure, let's expose that.
I mean, I didn't follow, but maybe somebody else did.
So the special consideration of I want create sequence 0, 1. So you're doing you're creating a vector that represents the indices. So 0, 1, 2 up to count. There's been desire for a well-defined property off vector of t. So we currently have all bit set 0 and 1 as available properties for well-defined constants. So this would be something like vector of t dot indices, or a similar name to represent that well-defined concept of I want create sequence 0, 1.
Fair enough. It sounds okay. It doesn't exactly sound like it belongs in this review, but I guess once we're adding create sequence, it sort of does. So
yeah,
I can.
It's the related concept of the purpose of this API is you're writing a generic algorithm and you need to create one of these well-defined values but you don't know the size of the vector. And so you can't do something like vector create and manually enter all the values in.
Sure. So is that on vector 256 of t?
Yeah, it'd be on the of t's rather than the non of t's.
Maximizing the amount of class definitions I have to write. All right, so on vector 64 of t, we then get public static is a get only property, or are the others read only fields?
They'd be properties. That way the JIT can treat them as intrinsic and generate the constant itself, since it will know the size, or use the appropriate API to do so.
Okay. So each vector of t gains a vector of t indices get. Okay. Yes, both Emo and I are in the office today, meaning we're both on laptops, and streaming is being fun. And of course, Emo's not even here, so now I'm on his laptop and my laptop, trying to drive the meeting twice, which is why you can't see what I'm typing. All right. So we added create sequence as the method because nobody objected. And we added indices as a static property on the mirror types. Right.
And that covers the nice ability to cover the creates the underlying index instruction in a way that is general purpose and fits in with our other create APIs. The rest of these will just be on SVE as documented. So we've got duplicate selected scalar to vector. Notably, I don't think that first one is necessary because there's no way to select. Is that right, Tamar?
Yeah, I was just wondering. I think that's pretty much just vector t.create.
Yeah. And then for the others, the index, that should be a byte index constant expected in all cases, correct? To match what we've decided elsewhere, since it's a directly encoded immediate.
Yep.
Yeah.
Yeah. So basically all of those compress down just to the byte index 1. And then we mark it const expected.
Oh, so the 3 that are not byte go away?
Yeah. And then you get the full set of generic overloads on that.
Okay, so the one with U long index looks like it has all the T's.
I think so. 1, 2, 3, 4. Yeah, it looks like all of them.
All right. So what about the one that doesn't take an index?
That one's unnecessary. That's just vector of t.create. There's no selected scalar or anything like that. It's just broadcasting. So it goes away.
Okay, so this one is deleted. And those are squished. Okay. I run reverse bits.
Yeah, and so reverse bits is straightforward. It's the same signatures we've got in advanced SIMD, just taking vector of t. The same goes for reverse bytes within elements and reverse element.
Okay, and then just singular plural, it's value in the other places and not values.
Yes.
Okay. All right. So reverse int 16 within elements.
I think in advanced SIMD we named that reverse element 16 and reverse element 32.
Okay, does that mean
And
that
then
the
it looks
parts,
like also reverse element 8 is what we did for the base one for
Yeah,
bytes
so-
within elements.
so does that mean the places that we used 8-bit and 16-bit as in friends as infixes here should have been suffix numerals? Or do we like what we did?
Sorry, I'm just looking at an example again. I think in the context, the 8-bit is the better name.
Okay, but on reverse element, because it's matching
Yeah.
what we've named something else, it's so reverse element singular or reverse elements plural?
It's singular.
Okay. Splice and move prefix.
Yeah, so the move prefix is just a comment indicating that it might emit a move prefix as part of the predication support because of RMW considerations. Splice is a new name. I'm not I don't know off the top of my head what this particular instruction does.
So basically, given the mask, it takes from the first source operand all elements until the predicate is no longer true, and then it takes from the second operand from that point on. So it basically concats two elements together based on the predicate.
Okay, and so if mask was true, 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 and then false, then it would pick the first three from left and the rest from right, regardless of what the rest of the mask was.
Yeah.
Okay.
It's designed for a combination and used for stuff like the SV break instructions.
Mm. And so it's similar in concept to a conditional select. It just decides a terminating point and ignores the rest of the mask.
Yeah.
And the underlying instruction name is splice, so splice is probably the right name here.
There's also a description of that one at the end of the API as well. Well, we've already described it anyway.
Yeah.
Okay, and then the ordering of mask left and right is correct, and those are all the best names?
I don't have that instruction open in front of me to say if it's the right order, but the names would be correct. It looks like, yes, the order is correct for the operands. And then transpose even, odd, unzip even, odd, vector table lookup, and zip high, zip low match the advanced SIMD names exactly.
That one was quick. Really long description. All right, create series became create sequence and moved to the non-generic vectors because they are the generic methods that infer the T's. Now that we have the create series / sequence on the vector types, this is what I heard, so tell me if I'm wrong.
Yep.
And we squished duplicate selected scalar to vector and then renamed these two guys. And then was reverse element supposed to go to reverse element 8?
Yeah, no, reverse bytes within element should be reverse element 8.
Okay. And reverse element is somebody knows what it does?
It instead of reversing a particular number of bytes despite what your input is, it reverses according to the size.
It's out of order. Deal with it. Okay. That button. That button. These buttons. Okay. Right. Showing Emo's calendar. First faulting.
So, Tamar or Alan, could you describe the difference for first faulting here versus non-faulting? If I remember correctly, these ones will throw if the first element is inaccessible, and otherwise it acts as non-faulting.
Yes, I think we got the non-faulting not quite correct on the review last time. So okay. the non-faulting one will never fault.
Yeah, I think that's what we said.
But then we left the mask on, didn't we?
No, we removed the mask from. No, we removed. Yes, we left the mask on for non-faulting. We removed the mask on for the normal load because that one's faulting.
Yes, but we want to keep the mask on the normal one so that you can avoid the faults if you want to.
No, because we said that the mask isn't. You do it via conditional select because it's a normal load operation.
So for the one that can fault, we need to have the mask on that one because conditional select changes the behavior if you were to mask. Whereas for so basically the consideration is conditional select can be used when the behavior is semantically equivalent between the two. So if you were to load and then mask, you need to get the same exceptions as if you had loaded with the mask. So for the non-faulting ones, which never fault regardless of the mask given, it's safe to use conditional select. But for the ones that will fault unless it's masked, you need to have the mask as part of the API directly, because you can't represent it as a two-call sequence.
Right, so then Alan is right, we need to swap those two.
Okay. That's
And
in 94006, Jeremy. So I think we can just leave a note at the bottom, and then we can fix it up after, saying that the non-faulting don't need to take the mask because they never throw, whereas the faulting ones do need to take the mask because they can throw unless the element's masked off. So it's just we got the where the mask goes swapped between the two of them.
And it should be inserted into where?
Into the ones that do fault instead.
Which are the ones with no like words in them?
Yeah.
Sure. Good enough. Thanks, Emo.
What will become important for the first faulting ones as well? So the non-faulting ones, if it would have faulted, then it sets the FFR register to say which elements would have faulted.
Okay. And that is how is the FFR normally accessible?
There is a API method at the bottom of this set.
Okay.
For reading and setting.
Okay.
So
that should be fine then.
Yeah, it's also important to state that the core can actually give you false positives here.
Mm-hmm. And so for this first for the gather vector first faulting, outside of the first one, if the mask is present, it doesn't fault. And is that the first active element that it considers for the fault?
Yes.
Okay, so we do need to take the mask here as well.
Yes.
Yeah. Okay.
So inactive
these
element,
first ones should be correct.
Yeah, inactive element will never fault anywhere.
Yeah. So then
changes that we need to make to the signatures, or are they good?
Yeah, the changes are basically the same as we had on the other gather API. We're dropping the ones that take the scalar directly. The ones that take the offset, we're going to insert whichever terminology we had agreed upon, like with byte offset, after the vector t name. So gather vector byte with byte offset, 0 extending first faulting. And then the same consideration of there's ones that are named int 16.0 extend, that should be uint 16.0 extend, and int 32.0, that should be uint 32.0 extend.
And so like gather vector byte 0 extend first faulting mask address offset is gone. So the ones that take just a single
long offset. Yeah, those are gone for consistency with our other decisions.
All right, so where's this guy here? So this guy is gather vector with byte offset first faulting.
Faulting. Yeah.
And gather vector first faulting, mask address offset goes away. Or only,
for which one?
So these two go away because they say
Yeah,
long
and
offset.
so do the long index ones.
Okay. All right, gather vector int 16 sign extend stays what it is. The first two, because they don't take offsetty things, but then these two get with byte offset.
Yes.
And these two stay the same, and then the next two get deleted. Next four get deleted. So now we're at the int 16.0 becomes uint 16.0. And we add some with byte offsets. But not between 0 and extend. Then we delete the next four. I'm guessing we repeat this for 32-bit.
Yeah, and the zero, just remembering the zero extend have the U prefix in front of them for the integer sizes. So int 16.0 extend should be uint 16.0 extend.
Yep.
Yep.
We'll say indices, these end with a scalar. Does this end at 32, or am I going to find 64 when I'm?
It ends at 32 because 64 can't zero or sign extend to 64. It just is.
Fair enough. I'm surprised they don't. I guess it's true. None of these say 120 or int 128. Or S byte. S byte shouldn't gain with byte offset, right? Because it's offset and index are the same thing.
Yeah, so we just need the index one.
Have we been consistently calling that one index or offset? Just write down a note that says we should double check.
Yeah.
And then delete the scalar ones on that. Okay. And then now we're to FFR.
Yeah, so this could potentially be expanded. The FFR stands for first fault register. So like was described at the beginning, it's a internal register that tracks the mask of the fault that occurred. So we could keep it get FFR, or we could expand it out explicitly to get first fault register. or get first vault.
The word register seems inconsistent with everything else we've got.
Do we have a similar, like, read of a special register from any other ISA to see what we did there?
Not really. The closest thing is CPU ID on x86, which is just called CPU ID.
Okay, we don't have like read flags.
No, the flags are typically propagated up through a bool.
Because, yeah, I mean, this one's tricky. Like, our naming rules are, if people know the acronym and not what it stands for, then use the acronym. So HTML, we say HTML because very few people know or care that it's hypertext markup language.
Yeah.
So I don't know if I mean, I don't know if this is the people who know it would know it and those who don't would never need to read it, or what.
In the context of using the platform specific APIs under system runtime intrinsics, ARM SVE, my guess would be that users are either learning or already know about the concepts directly related to SVE, and so using the acronym is safe, quote unquote. You're likely going to have or be familiar with the architecture manual for many of these, since you'll want to understand what the instruction is doing, any edge case behaviors that might need to be considered, etc.
Okay, and then normally we say initialisms that hit 3 letters become Pascal cased. That feels,
I think that's
weird
fine
here. Okay.
It's consistent with we've tended to not do all caps for any of the other intrinsic APIs. So I think being consistent with the naming with the .NET casing convention is goodness.
Okay, so get FIFR becomes get FIFR, but with a little f and a little r.
Yeah.
Okay.
And we've just got load, first faulting, with the sign, and zero extend with zero extend should be uint 16, uint 32. And then we've got set FIFR and write FIFR. And I think we just need write FIFR. And for consistency with the .NET initialisms, we should probably call it set so that it's get and set. Because all that the parameterless version does is it's effectively write FIFR, but with value being all bits set, correct? Tamar, Alan, it's going to set it to all bits set rather than clear, correct?
Yes, set FFR is all true.
Yeah.
Okay, and is it? I'm guessing it's a smaller encoding to call set FIFR instead of write FIFR because it needs the register to go read from.
Right,
I was wondering,
but
would we erase the zero argument overload?
what that's what I was saying is that I think we can just have set FIFR and we can always take the value and we can pattern recognize when the user passes an all bits set.
Okay, so you want to delete the zero argument overload.
Yeah.
And rename write FIFR to set FIFR.
Yeah, that way it's consistent with get set and it doesn't expose an overload unnecessarily. And if we determine that users are really annoyed at having to type set, all but set, then we can consider a overload or alternative name in the future for that special condition.
Okay. So consistent, the changing of base and bases to address and addresses, inserting with byte offset as needed, which I might have gotten right. Long offsets were deleted. Insert the use for zero extends. The note about consistency just to double check. And then get FIFR, write FIFR, and set FIFR.
Yeah.
Okay. And is there? Okay. Was that? Did we finish, or is there another one? And does it fit?
There's more, and so there's 4 more, one of which should fit in the next 15 minutes, and that's 94009. And then after this one, the ones that are left are the store and scatter APIs, and then the couple load ones that we skipped over because we wanted more people to discuss the X naming. But this one should be fast because it's effectively just exposing APIs that we already have names for, follow the existing pattern, and which are just taking the variable size vector. So we've got abs and absolute difference, and that is an existing inconsistency we have between the two names. Add and add across, where add across is doing a reduction operation. So it's effectively sum. Divide, and then we've got dot product. I believe the im index should be byte const expected byte.
Yeah, but did we really call them op 1, 2, and 3 in other dot products?
For dot product, one of those. Actually, I'm not sure what the third parameter is for this one. Tamar or Alan? Trying to look at the DP namespace.
One of them should be the accumulator.
Oh, it's the first one should be add end and then left right.
So dot product of addend left and right.
Yeah. And then the second overload should be dot product by selected something. So for DP we called it dot product by selected quadruplet. What is the selector in the case of, is it just scalar, or is it something else for the variable length vector, Tamar, Alan?
It's usually still an index, yeah, a scalar index.
Okay. So it is just scalar.
Yeah.
Okay, so the second overload should be dot product by selected scalar, and then const expected byte index. And then there's going to be a couple others further down for the fuse multiply adds that are the same fix up.
Okay, so it gains by selected scalar, and then the parameter changes from ulong im index to byte index.
Yeah.
And that's still addend left right. The thing didn't change it.
Yeah, it's still addend left right, and then it's we call it right index to clarify that it's specifically selecting the scalar from the right value.
Okay. Okay, so fuse, multiply, add sounds like words I've seen before.
Yeah.
And what am I changing on this ulong immediate index?
That's const expected byte right index again, because it's fuse multiply add by selected scalar.
Okay, so add the by selected scalar.
Yeah, for the ones that take the byte index here.
Yeah.
And then it looks like for fuse multiply add negate, it should be negated, so a D at the end.
Just a quick question. So do we just want the one method for both FM add and FMLA? Because while operation
for which one?
For from FMLA and FM add. Because then the order doesn't really match the instructions for at least one of them.
It looks like we just have the one for it looks like we just have the one for advanced SIMD.
Yeah, but advanced SIMD doesn't have FM add. So the difference is in. Sorry?
Is the difference just the parameter order?
Yes, so it's usually important because it determines which register is destroyed. So if you're accumulating into something that's constant, typically people would avoid using FMLA.
So in this particular case, the prior art would be on Xarc. There's actually 3 different instructions for each FMA operand. So there's actually VFM add 132, 213, and 312, and that indicates which 2 parameters are multiplied together versus which one's the addend and which one's being destroyed. And in that scenario, we actually only expose the one intrinsic, and the JIT picks the encoding based on which operand is RMW or last use versus not. Otherwise, users are going to get the wrong code gen if they trivially choose the wrong overload.
Okay.
So the
Makes
JIT
sense.
really has to recognize it regardless.
Okay. So fused, multiply, add, negate. Again, op 1, 2, and 3 are
Yeah,
not-
that should be add in left, right, and it should be negated with a D at the end.
Okay. What gets negated?
I believe it's the result of the multiplication is negated, correct?
Sorry, I was on mute. Yes.
Yeah.
Okay, so it's not negative addend. It's basically a -1 gets inserted with one of the left or right equivalently.
Yeah, multiplies the value of the first two, negates the product, and then adds the value.
Sorry, you said multiplies the first two. So do we have add in?
It multiplies the two multiplication operands and then adds it to, and the add is the first operand. Sorry, I'm just.
Yep. Just you said first two, and then I just got defensive. All right, fused, multiply, subtract. I assume that's const expected byte right index.
Yep.
Fused, multiply, subtract, negated. Minuend, left, right.
Yep.
Okay. What's max do?
Exactly what it sounds like. So it does a per element maximum
positional
operation.
And that's right. Okay, so max is pairwise, and we've not been saying pairwise.
Not pairwise, it's element wise. So pairwise is element 0 with element 1, whereas both from the same vector, whereas element wise is left 0 with right 0.
Okay. Not the way I would language, but sure.
Well, we do actually have a pairwise as well in SV2, so you don't want to name this one pairwise.
No, I get it. I'm just saying not the way I would have languaged the word pairwise, but if the ISA did it differently, then let's match the ISA.
Every ISA has done it differently.
We all do. I am the arbiter of all languages.
So max is element wise maximum. Max across is a reduction operation where it's computing the maximum element across the entire vector.
And
max number
across the whole vector.
Huh? No, it returns a scalar result in a vector register.
Okay. I'm sure people who call it will figure out what to do with that.
Yeah. It's the same as all of our other APIs that do across operations. Max number follows the same thing as math.maxNumber, which is it follows the IEEE 754 specification. Instead of propagating nans, it propagates the
non-nans.
The non-nans instead. Then we've got min across, min number across. Should be self-explanatory. Got multiply, where the index there on the second one, it should be multiplied by selected scalar and const expected byte right index. And then we've got regular multiply add, which take integers, and the reason it's not fused is because there is no difference for integers between a fused and non-fused operation in computed result. So that's consistent with advanced SIMD.
Okay.
Multiply extend.
Oh, I'm fine. I'm happy to take notes, but I don't have to.
Oh, it's just the whole time you've been gone, my face has been with your name on the live stream. So. All right, go ahead, Tanner.
So we've got multiply extended, which matches the name that we've got under advanced SIMD. I forget the exact behavior it does, but it's consistent in parameter ordering and functionality as that underlying one. Then we've got multiply returning high half, which I'm not positive that's the correct name.
I think we did something similar for normal ARM64, the scalar one.
Yeah, I just don't see another one named returning high half small 8.
It should be in base ARM64.
Yes. So in base ARM64, we've got S small l, which is multiply by selected scalar widening lower. And so I think this one would be multiply something upper instead would be the correct name. I don't think it's a selected scalar, so it would just be multiply. And is it a widening operation? No, so it would just be multiply upper. Or
I believe it's
multiply
just
widening upper.
So I believe what it's just doing is multiplying the same elements, and then because the resultant size can be bigger, it returns just the high half of the results.
Right, so it'd be multiply. I don't know if we've got prior art for that name.
So it should be, so base ARM64 has the exact same instructions on scalar as mod H, unless we didn't put an intrinsic for it.
I don't see one. We've got lots of ones that do similar things, like there's the SQD mol H, SQRD mol H. But I don't see S mol H or U mol H.
Might have missed one.
Yeah, so maybe we can come back to that one after we've had the opportunity to think on the name, because I don't think that's consistent with what we've done in other cases.
Yeah, so I did find the review, but there's no check mark next to it.
Okay.
So I think that one was this one.
Yeah, so I'd say let's leave multiply returning high half off of the approved list, and we can come back in a separate proposal with the with a name that fits our existing conventions and make sure it's covered for the advanced SIMD as well.
Okay, so delete multiply returning high half.
Yeah.
Mr. Secretary.
So what was the last thing you said?
So multiply returning high half, we're going to exclude from the approved list, and we'll come back to it in a separate proposal where we can make sure it's got a name that follows the suggested conventions and is covered for advanced SIMD, since we missed it there a couple years back as well.
That's good.
So it looks like it was approved, but never implemented. So this is the intrinsic for it.
Okay.
No, we missed it previously.
Oh, previously, as in this list previously?
No,
or-
like a previous ISA, we left it out. So,
Ah.
so we don't have prior art to fall back on.
Gotcha. So,
So
then, never mind
yeah.
then.
So I'd like to just think on the name a little bit and make sure we get it correct. And since we're at time, and that's the one that's not straightforward, we can get to it in the next review when we get the last few proposals done.
Okay, so I think we're up to multiply, subtract now.
Yeah, multiply, subtract should be straightforward, as should negate.
You have to scroll or
Yeah, scroll down. A little bit more. There we
Sign
go.
extends. Subtract, reverse, zero extend.
Yeah, and these should be matching our existing names for sign and zero extend, and then sign extend widening lower, sign extend widening upper.
Is subtract saturate the right name? I thought saturate was always saturating.
Subtract, saturate. You know, we just named it subtract, saturate.
Okay. And
We should notably not need subtract reversed. That one exists for the same reason as the fmad correct tamar, where it's just it's an alternative encoding for when the when one of the operands is not last use and the other one is.
Sorry, could you point this question again? I missed
So
it.
subtract reversed, it's just an alternative encoding for subtract when you want write to be the
Yeah.
destroyed register. Yeah, so I think we just need to subtract there, and we'll do the same. We'll do the same JIT LSRI scheduling to make sure the right thing happens and users don't pessimize themselves accidentally by choosing the wrong one.
delete subtract reversed.
Yeah. And that should be the whole set.
Okay, and then you have a section called optional.
Yeah, so the optional were the ones that take the scalars, and we decided in the past reviews we weren't going to expose those because we can just recognize the vector create scalar versions, and if that ever changes in the future, we can revisit adding them. So don't expose things unnecessarily.
so all the optional ones we exclude basically?
Yeah.
All right.
By the way, Tanner, I found that it was implemented, but probably the top level ticket wasn't updated. So that's the pull request that adds it as multiply high.
Okay. We'll be able to get to that one in the next review, and because we've just got scatter and store left, and so we can get this one done as part of that.
Didn't clean it up.
I just ended up with taking the notes. I did not make modifications except for removing the optional entries.
Yeah, so I think it has all of the edits except the two removals. So we'll just take out the two removals.
Yeah.
That works. So what are we marking this as then? As approved or as?
Yep, because the ones that got cut will be
Right.
Subtract reversed is what got deleted.
Yeah.
Sweet. So then in terms of next time, so I think there's still a ton of, I just stopped sharing my screen. That's great.
There should be just 2 more proposals basically, and then the minor proposal that covers that's going to cover multiply high and the load vector X APIs, where we want enough people to actually discuss the names on them and what the casing should be.
So then should I set up another meeting with our guests here?
Yeah, just one more should be enough to get through the rest.
And they are probably the same, volume, right? So another 2 hours probably. Yeah, it looks like it.
Yeah, I'm
would
not sure
next-
we'll use the whole 2 hours since they're just scatter and they're the equivalent of the loads that we've already reviewed. So hopefully we don't use the whole 2 hours, but we should
Don't jinx
probably
it.
plan
To make
for it.
announcements like this, we're gonna use 3 hours. That's how these things go. So does Thursday work, or
Yeah.
yeah? All right, then I will set up
That's works
another
for me.
meeting for next Thursday for the same time slots for ARM, and then we use the Tuesday one for whatever else we have on the list.
Sounds good.
Awesome. Thanks everyone, and then enjoy the rest of your day and the weekend.
Cheers. You too.
Fantastic. Cheers. Thanks.
Bye bye.